All right, this is the Algebra 2 Trigonometry and Unit Circle review. All right, this is first question are asking which quadrant or quadrants can theta lie under the given conditions. So remember, cosine is x and sine is y. So what I like to do first is draw my trig chart. This is quadrant 1. This is quadrant 2. X is negative in this quadrant. This is quadrant 3. They're both negative in this quadrant. And this is quadrant 4. Y is negative in this quadrant. So number 1 wants to know which quadrant is cosine and sine both positive in. Well, that's only the first quadrant. The first quadrant, x and y are both positive. Number 2, sine and tangent are both negative. Remember, sine is y, tangent is sine divided by cosine, or y divided by x. So that means tangent is going to be positive in the first and third quadrants, because a negative divided by a negative is a positive, and tangent is going to be negative in quadrant number 2 and quadrant number 4. So which quadrant is y negative in and y divided by x both negative in? Well, that's only quadrant number 4 here. The y coordinate is negative and so is tangent. And the last one wants to know which quadrant is cosine or x negative in and sine is positive in. That is only quadrant 2. Next section is referencing the reference angle. Number 4 wants to know what is a reference angle. So there's a lot of attributes we've talked about, but basically it's the shortest angle measure to the x-axis from the terminal side of an angle. You could also say the reference angle is always positive. It's always acute. You can include those as well, but that's the definition. So number 5, they want us to find the reference angle of 140. So what I like to do is I like to sketch the angle. 140 is going to be in quadrant number 2. I like to piece it apart. That's 90 and that's 50, adds up to 140. So the reference angle from the terminal side is going to be that shortest distance to the x-axis in green. And of course that measure would be 40 degrees. Number 6, 205 degrees. Same thing, 205 is across the x-axis plus a little bit extra. So the shortest distance to the x-axis from the terminal side is going to be this angle measure right here. And this piece is 90. This piece is 90, which means this last piece has to be 25. Those three have to add up to give you 205. So our reference angle, 25 degrees. So this next one, not drawn to scale, but you can see 355 is measured in red. We know there's 360 degrees for one full revolution. So that means this little piece is the reference angle, the shortest angle measured to the x-axis, 5 degrees. Number 8, reference angle is always positive. 58 is already an acute angle, so the reference angle for negative 58 is positive 58. If they give you the angle measure in radians, your answer needs to be in radians. So that's for number 9 and number 10. So when we sketch this angle 4 pi over 7, we know it's somewhere in between 1/2 and 1 full pi, which means it's going to be in quadrant number 2. So it's a little bit bigger. Remember, this up here, 90 degrees, is pi over 2. This right here is 180 degrees. This is pi. So 4 pi over 7 is going to be somewhere there in quadrant number 2. The reference angle is this little piece left over right here, the shortest angle measured to the x-axis. So to find that angle measure, we're going to take pi and we're going to subtract the angle measure in red, 4 pi over 7. And we end up with 3 pi over 7. Some of you may sometimes convert this to degrees, find the reference angle, convert it back. That wouldn't work on number 9 because when you convert this to degrees, it's an irrational number, or sorry, it's just it's an ugly decimal that you'd end up having to round. So this one you really do have to solve the way that I just showed there on number 9. Number 10, 7 pi over 5. So that's the same thing as 1 and 2/5 pi. So that means it's going to be in quadrant number 3. So I'm going to sketch this angle, where this is pi over 2, this is pi, this is 1.5 pi or 3 pi over 2. So I sketch this angle, 1 and 2/5 pi. It's in the third quadrant somewhere. We're not really sure where. But the reference angle is going to be this angle measure right here, that shortest angle measure to the x-axis. So to find the angle measure in green, we've got to take the full angle measure, which is 7 pi over 5, and we need to subtract pi radians. And that will give us that little leftover reference angle P. And we end up with 2 pi over 5 radians. This one you could have converted to degrees, got the reference angle in degrees, and then converted it back, and it would have worked just fine. All right, on this page, I'm going to use the unit circle. Now, you won't have access to this on the test, but you can certainly fill one out. I'm going to leave a blank unit circle on the test that you can fill out to make this next section, 11 through 16, much easier. So number 11, they want us to find the exact values for sine, cosine, and tangent of 210. So the cosine, doesn't matter which order, the cosine of 210, remember that means the x-coordinate. So find 210 degrees on your unit circle. The x-coordinate 210 degrees is negative radical 3 over 2. So that's cosine. To find the sine of 210, that's going to be the y-coordinate at 210 degrees, which is negative 1/2. And then tangent's the one you've got to show some work for. Tangent is y divided by x. So we're going to take the y-coordinate, which is negative 1/2. And divide it by the x-coordinate, which is negative radical 3 over 2. And then flip and multiply and simplify that. And you end up with a radical 3 over 3. So most of this section right here can be done using the unit circle, and a little bit of work has to be shown using this y divided by x formula. There's a couple more of the answers, number 12 and number 14. Save a little bit of space. I abbreviated my trig functions as C, S, and T. Make sure you watch out for the negative and positive values. If the actual answer is negative radical 2 over 2 and you put positive radical 2 over 2, since there's no work to be shown here, you don't get any partial credit. So take your time when you answer these. And there's the rest of the answers. Keep in mind number 15, 9 pi over 4. That one is a full revolution around the circle. It's 2 1/4 pi. So 9 pi over 4 ends up going a full circle and then coming right back here at 45 degrees, or pi over 4. So there are the questions that you can use the unit circle for. So let's talk about coterminal angles. Okay, more than one way to write your definition here, but coterminal angles are two angles that have the same initial and terminal sides but rotate coming from a different direction. It's not mandatory that you sketch these, but I think it's helpful sometimes. So number 18, if we sketch negative 95 degrees, that's going to end up right here. So that's the original angle, negative 95. We've rotated clockwise. So the rotation coming from the other direction is going to be a positive angle. So we know our answer is going to be positive something. And to figure out that positive something, since there's 360 degrees in a full circle, we're going to take 360 and subtract 95. and you end up getting positive 265 degrees. Number 19, the original angle is positive, so that means the coterminal angle is going to be negative. It's going to be coming from the other direction. Together they're going to make a full revolution, so 360 minus 35 is 325. And you just have to remember to stick a negative on there. Remember, it's the absolute value of those two numbers that add up to 360. All right, and then number 20 and 21, I left those problems off here on my worksheet, but those should be the problems. Those are the original angles. These are in radian mode, so your answer needs to be in radian mode, but it's the same idea. The original angle is a positive 2 pi over 3, so that means the coterminal angle is going to be negative something. Instead of subtracting it from 360 degrees, we're going to subtract it from 2 pi. So take 2 pi and subtract it. Take 2 pi over 3 and subtract it from 2 pi. So we're going to get a common denominator and then subtract. The coterminal angle is going to be negative 4 pi over 3. And then finally, number 21, the original angle is negative, so that means the coterminal angle is going to be positive. We don't really need to write the plus sign there, but I'm going to, just so in case I forget. And then we're going to take 2 pi